Welcome back. Our last speaker today is Dr. Paula Pedraza Peñalosa, a research associate at the New York Botanical Garden. She earned her PhD from the City University of New York, and her research focuses on the taxonomy, evolution, and conservation of the flowering plant family Ericaceae. She leverages a variety of tools in improving the botanical knowledge of the tropical Andes. And today she'll tell us about documenting the flora of a diversity hotspot, Las Orquídeas National Park, Colombia.
Let's see. Do you hear me well? Is this good? Okay. So it is very exciting to be here today, and I welcome you to my symposium titled The Vascular Plants of Las Orquídeas National Park, Colombia, Documenting a Diversity Hotspot. Through this floristic work, I want to illustrate how Colombia is an exciting horizon in the botanical exploration in the Neotropics. But before I dive into the floristic project itself, I want to explain what it takes for a region to be considered a biodiversity hotspot, how this is pertinent to Las Orquídeas National Park. Then I'm going to talk about the flora and some of the products. To identify biodiversity hotspots, we usually use 3 indices as surrogates of biodiversity. These indices are species richness, endemic species, and threatened species. The distribution of these indices are mapped for a given region, and then these maps are superimposed. The resulting maps are superimposed, so we can find those areas where they concentrate the most. This is illustrated by this figure. Here we have angiosperm species distribution patterns for the Neotropics, and you can see that the higher concentration of species is represented by the darker areas. Those areas where we have the most concentration of either one or all these indices are our priority areas or hotspots for conservation. In global studies of angiosperm diversity, we find that Western Colombia has a high concentration of species richness, represented by the darker colors, as you can appreciate here. And in Western Colombia, we find parts of 2 extremely important hotspots at a global scale, the tropical Andes and the Chocó biogeographic region, that I'm going to shorten here as CHOCO. It is in Western Colombia, and more specifically in the Departamento of Antioquia, where we find Las Orquídeas National Park in green. And this park is strategically located in the confluence of these 2 very important hotspots. What I mean by this is that the higher altitude areas of the park are part of the Colombian Western Cordillera, which is the westernmost branch of the tropical Andes. The lower lying parts of this park towards the Pacific are part of the CHOCO hotspot. The CHOCO hotspot occupies all the Colombian Pacific coast from southwestern Panama to northwestern Ecuador. The altitudinal limits towards the east are more loose, and depending on the author, they can go from 500 meters of elevation up to the crest of the Cordillera to 4,700 meters of elevation. And going back to what Alejandra presented, depending on the definition, it will include some parts of the Magdalena. So I'm going to a definition more restricted of the Chocó in this presentation. The Chocó is better known because of the lush, very pluvial forests. But the Chocó is not a uniform region. It's very complex, and it has a multiple geological origin. Actually, in the Chocó, we find some of the rainiest places of the earth with an outstanding annual rainfall. And we know that high precipitation is correlated with high levels of biodiversity. And that is how in this teeny tiny region, we have nearly 3% of all vascular plant species, and at least 20 ecosystem types. As for the other hotspot that makes up the flora of Las Orquídeas National Park, the tropical Andes is of undeniable importance. It is the top hotspot of plant diversity in the entire world. We find there 30,000 to 40,000 vascular plant species. At least 50% of them are not found anywhere else. They are endemic. Unparalleled diversity in the Andes, unfortunately, comes with unparalleled levels of habitat degradation. This is the latest data that I found for the tropical Andes region, and we can see here deforestation rates. This is the small bar here in the lighter blue, represent deforestation rates for years 2001 to 2005. And the taller bar for Colombia represents years 2006 to 2010. And as you can see, in Colombia, deforestation is on a growing trend compared to other Andean nations. Plant diversity in the Andes, in the Colombian Andes, it is outstanding. There are at least 50,000 vascular plant species recorded, and they represent 50% of all neotropical vascular plants and 60% of the Colombian vascular plants. Historically, Colombia has been in a state of internal conflict for over 50 years, and it has become a sort of black hole for botanical information. The international community has been hindered from collecting in Colombia and collaborating with Colombia, and the same has happened to the national institutions because of the same safety concerns and lack of funding. And this has affected negatively the rate of herbarium exchange within the country and outside of the country. So even though we have known for many decades that Colombia and Western Colombia represents an important region for botanical exploration, it remains under study given its importance. To bring back the attention on the Colombian Andes and Chocó was the main motivation of our project. So the main objectives were to catalog the vascular flora of Las Orquídeas National Park, this way to increase botanical knowledge of top priority areas, to enhance data accessibility, and to develop tools for conservation for this important region. I'm gonna briefly talk a little bit more about the park, of this amazing park. Within a very small area in Las Orquídeas National Park, we find a very sharp gradient of altitude. And this, combined with a lot of variation of the precipitation, geology, and geography, has given rise to a very heterogeneous flora. In Las Orquídeas, we have three main altitudinal belts. We have the Chocó rainforest that reaches 1,000 meters of elevation. We have the extremely rich pre-montane forest up to 2,000 meters, and that is topped by the montane forest that reaches 3,100 meters of elevation. Las Orquídeas Park, here in green, is a very isolated park and of difficult access, to put it mildly. The park can only be reached from a little hamlet called La Encarnación, which is 3 hours by car from the closest town, Urrao. Urrao is 12 hours from the capital city. There is only one main access, and the access is only by foot or by mules, and it takes a whole day to get from La Encarnación to the first cabin right at the entrance of the park. Actually, this first cabin is not even within the park because it was built on the wrong side of the river. If you want to collect in the park, you still have 1 to 3 days of additional travel. The ancient footpaths of Las Orquídeas are very steep and windy, and sometimes they are turned into very narrow passages that are carved deep into the mountains. Sometimes the paths just completely disappear, and you are forced constantly to shift into an amphibious mode to cross the many rivers and streams that irrigate this very rainy place. When we look at these historical collections from Las Orquídeas, not surprisingly, we found that the majority of them are along the main axis or around the main cabin. So that meant that to document this flora, we have the whole park to explore. And this dictated our fieldwork strategy. It was necessary for us to target little explored areas or areas that have never been botanized before. We made 6 big expeditions, and before many of these expeditions, it was necessary for us to send scouting trips, like advanced trips beforehand, so they could check the conditions and start opening the trails. And sometimes we just ran out of trails and we have to scramble up and down to get to our plants. The park rangers were absolutely instrumental in this effort and in building the 5-star accommodations where we have our laboratories and that were our home for many, many days. Another field strategy that we employed was specialized collecting. We invited specialists and young systematists to come along and help collecting groups that are either hard to identify in the field, groups that are hard to collect, that are very labor intensive, and groups that are very diverse, such as ferns, monocots, and among them, the orchids. Botanical exploration of the tropics can be sometimes too concentrated on tree-like forms, on woody plants. And we knew beforehand that that would be the wrong approach for these pluvial forests that are covered in epiphytes. For that reason, we also adopted a balanced tree, non-tree, and epiphyte collecting strategy. What this meant in practice is that we made ourselves incredibly busy, and every day we have more plants than we could ever dream to process. Now I'm going to move on to the latest results. This is a dynamic flora that gets updated every time that we receive a new identification. Botanizing in little or never explored areas really pay in many ways, some of them unexpected. We discovered the first paramo locality within the park, and this way we were able to add a whole new ecosystem at the top of the altitudinal belts. The paramos in Las Orquídeas are reached up to 3,400 meters of elevation. These paramos are locally known as the balding spots. Balding spots because in reality they are like very high peaks that reach beyond the tree line, as you can see in this picture, that is looking back at our camping site. Is looking back at our camping site where we pretty much occupied the only flat land of this little paramo patch. Paramos are extremely rare, very biodiverse and important, and they are actually protected by the Colombian legislation because they are key to the water supply of millions of people. So this was a very exciting finding. If we look at the flora of Las Orquídeas in terms of numbers, so far after 3 years of herbarium work and field work, we have documented 176 families, 756 genera, and an outstanding 2,476 species of vascular plants. There are many new records, there are many, many new novelties, and some of the novelties include epiphytic herbs like this chestneraceae, Rimonia betancouri, which is thought to be endemic to the park. The novelties are not only found in plants that we only saw on one occasion or that were rare or that are cryptic. Some of them were actually very large trees, like Magnolia frontinoensis. Magnolia is a very important genus for the Neotropics, and the collections that we made in Las Orquídeas allowed the specialists of this group to be sure that this was a new species and to figure out that it was present in other localities of the Colombian Western Cordillera. Speaking of the Colombian Western Cordillera, just to put this number into perspective, other protected areas in this very rich region still don't come close in terms of diversity to Las Orquídeas National Park. It is important to say that there are more species to be documented in this park. We were not able to collect below 800 meters of elevation because these lands are inhabited by indigenous people and we lack the proper permits to work in these areas. To our knowledge, these areas remain completely unbotanized. Collecting tall trees and canopy epiphytes is very hard. It's even harder in steep, wet forests, and sometimes it's just plain impossible. So it would be advisable in the future to do field work just concentrated in this particular group. On the other hand, we have some specimens could not be identified. We have the specimens, they represent the species. We don't know if new or not, but we have too poor of a knowledge of this general area to work them out. And there aren't specialists or tools for us to use to identify them. There are very difficult groups like Orquideas, which is the most diverse, but it's also the worst resolved. Orquideas is a difficult group. In the field, you can completely miss it, like these teeny tiny lepantes, and it's very hard to work with them in the herbarium as well. Orquideas are red listed, and they could not leave Colombia to reach a specialist for identification. And within Colombia, we didn't have a specialist, or rather a team of specialists that would be able to identify them within a reasonable time. If we look at the floristic composition of Las Orquídeas National Park, as you can see here, these are the topmost species-rich plant families. Orquideas is at the top, as I mentioned before, with almost 300 species, and is followed not so closely by Rubiaceae, Melastomataceae, Piperaceae, Araceae, Gesneraceae, Ericaceae, and Bromeliaceae. When we look at the families with most rich in genera, we have Orquideaceae and Rubiaceae still at the top, and Melastomataceae and Ericaceae are still among the most prominent. It is important to notice here that Asteraceae and Poaceae make an appearance, and these two families, along with Ericaceae, are families that are dominant of flora of higher altitudes. I'm talking about montane and paramo vegetation. And this is speaking of the Andean influence of this flora. We also have among the most prominent Ericaceae, which is family that pretty much defines Chocó forest. Ericaceae is one of the most prominent families in Chocó forest. Piperaceae is also extremely important in these regions. It is also important to note that we have more non-woody groups among the richest in species in Las Orquídeas: Orquideaceae, Piperaceae, Araceae, Ericaceae, and Bromeliaceae. And this is very much in line with what you find in a Chocó forest. Only 5 to 10% of the taxa are large woody species, and about 50% of the taxa in a given area are non-woody plants or epiphytes. And this is in sharp contrast with what you will find in an Amazonian forest, because in the Amazonian forest, the most prominent groups are woody plants and large trees, and you have a big representation of lianas. Here, you have more non-woody plants and lots of epiphytes. The flora of Las Orquídeas is not made up of genera that are very rich and specious. Piper, this gorgeous representative of Piper. Piper is the only genus that has more than 50 species. In fact, the majority of the genera in Las Orquídeas National Park are monospecific for this region, meaning that they only have one species in the region. And when you put that together with those genera with 2 species, they make up for 70% of the entire, of all the genera. In other words, the flora of Las Orquídeas is made up by an assembly of many, many unique lineages. And this speaks of another layer, another way of seeing the importance and biodiversity of this flora. To close the floristic part of my presentation, I want to talk very rapidly about the importance of specialized collecting for groups that are thought to have radiated in northwestern South America, groups like Ericaceae. Ericaceae is a family that is abundant and very dominant in high altitude vegetation. They are dominant in the montane forests and in the Páramo. However, in Las Orquídeas, we find Ericaceae throughout the entire geographic range. Today, Las Orquídeas Park is the place with the most Ericaceae species in the Neotropics. There are 79 species of Ericaceae recorded there, 10 of them new to science. To me, as a specialist of Ericaceae, it is very interesting that 7 of these 10 new species are all within the genus Samisia. And some of these species share many similar characteristics. And sometimes, they have been historically very hard to tell apart from herbarium material, because once you press the flowers, you lose all the tridimensional information. Moreover, sometimes even seasoned botanists are mystified by the green flowers and describe these incorrectly as fruits. So to me, it was extremely important to be able to go to see them in the field, to document them properly, and to take photographs. Now I want to move into the products. So we were able to catalog the vascular plants of Las Orquídeas. We produced an electronic checklist. This is a snapshot of how the web page looks like. And this is hosted by the New York Botanical Garden. There you will find links to thousands of herbarium specimens and an abundance of images, probably more images of plants that you will ever want to see. Also, through the project, we were able to give herbarium specimens from Colombia to many herbaria and plant specialists around the world. And we are hopeful that this material will instigate future work in this important area. We produce several tools for conservation and we also work with education and outreach, but here I want to highlight the 5 photographic mini guides that we made in Spanish that cover the epiphytes, the Páramo plants, the orchids, the common plants, and plants of importance for conservation. These guides were freely distributed, of course, among the park rangers, but more importantly, among the locals in the reservation and in the schools. We also put together a traveling exhibit about Las Orquídeas National Park that was placed in key places in the area and in Medellin, which is the capital of this of the department where the park is located. And links to these mini guides is found also in the website, in the checklist. This way, I have reached the end of this presentation. I, of course, have a myriad of people to say thank you because this is a team effort. But I want today to publicly acknowledge my Colombian counterpart, Julio Betancourt from Universidad Nacional de Colombia, my funding institution, the National Science Foundation, and especially the Unidad de Parques Nacionales de Colombia, because they truly supported this research and the difficult logistic parts of it. And with this, thank you for your attention, and I'll take any questions.
Yeah, so I question is not specific to, the botany side. In the beginning, you had like a DIS tool that sort of had, number of angiosperms per square kilometer as sort of a metric that you use to measure biodiversity. Is that, that tool, is that something that spans the globe? Is that, from a botany perspective, how are people, categorizing this? And is it a shared tool that, people around the world are using?
Yes, yes, absolutely. So actually, I had a bunch of slides on that topic because it fascinates me and I have to take them out because of time. But these are global studies. So these are studies that are made out for the entire planet. There are many of them because it takes years to come through the information and do this very difficult analysis. So the classification for hotspots had been made at a global scale. At a regional scale, you find different tools, and sometimes they concentrate on certain groups of plants or smaller regions. It has been done also just for the Amazonia, the Brazilian Amazonia, and so on. Yes.
I normally think of, as you pointed out, the Ericaceae are normally a montane tropical family. Can you speculate as to how it was that the Ericaceae managed to invade and colonize the lowland elevations of this park?
Sure. It is an interesting question. I mean, they're all theories, right? We don't know for sure. But I think it has a twofold answer. One is that we just tend to generalize, and we generalize for many things in our lives, and we have been told that Ericaceae is a montane group, and actually we have Ericaceae in mangroves. It's not only here in Colombia, it's in many other places. One requirement for Ericaceae is that it likes very humid places, and as long as there is humidity, and it isn't extremely hot, they are going to be happy. And I think that's why they are there, and probably they have been there for a very long time.
I can think of some Ericaceae that like hot, dry climates.
Well, some, but not this tribe. Yes, not this tribe in particular. Yes, please.
So I was talking about Piper and how its diversity goes down when you go up the mountain. However, in your general study, because you study a mountain range that was like 1,500 or 800 to 3,000 meters above sea level, what is the general pattern that you found? That there is more diversity in the lowlands than in the highlands, or if you match all plants, then the diversity continues and it doesn't go down the mountain?
Yes. So one of the ambitious things that we wanted to do at the beginning of the project was to, once we have our floristic data, was to attack this problem of the diversity distribution altitudinally, right? Because there is the expectation of diversity to peak around 1,500 meters of elevation, and that is what has been proposed. And there is the problem with the Chocó flora that we cannot discern very well where it stops and where the Andean flora starts. So there is this gradient. So the idea was to document all the diversity and start looking at the distribution of these species. And once we got into the field, we realized it was a little bit of an impossible task, that we were ahead of ourselves. It's really overwhelming. It is really overwhelming. And what we found with the participation of specialists, like the fern people and all that, is that there is so much diversity that goes unseen, that for sure you have less species high at the top, but you have many unique species there. But I wouldn't dare to put, a limit to it, because I realize it is very little what we know about actually happens in the field.
So I'm interested in the diversity that you show. The generic diversity is very high compared to the species diversity. And when I look at floras in the Neotropics, that's not the pattern you see in other floras. Like, for instance, in the West Indies, with a similar amount of genera, you have like 5 times as many species that you find in the park. So do you have any explanation why the species diversity is so low compared to the generic diversity? As you mentioned, there are a lot of genera that are monospecific, but could that be that, since that have not been discovered yet, or what would be your explanation?
It is quite interesting. I think there is still a wealth of things that we have not been able to document, that we collected and we just cannot name. But I also think there is the fact that this area is key for the radiation and speciation of many groups, and not only with the rise of the Andes, but also with the connection of Central America and South America. So to me, it is not surprising that we have so many unique lineages in here, and it's definitely a region where we have worked very, very little in the past.
Maybe one last question before the panel here. A question online. To help study the inaccessible epiphytes in remote areas, can one use waterborne or airborne genetic material as done with COVID studies in wastewater and wildlife diseases in the air? And he's referencing a study in Nature, Ecology, and Evolution.
Oh, that's very interesting, because I was reading a couple of days ago an article about it and thinking about it, so it's very timely. I wish, but the realistic and sad answer is no, because these studies work when you have a library to compare with. So you will end up with a bunch of sequences with no names and no types that are biologically meaningful. So this only works for things or areas that are well known, or you can like catalog and document the genetic diversity beforehand, but not for areas where we have never been. Okay, thank you so much.
Thank you. I'd like to now invite all